All right, welcome back to the Agile Track. I'm very interested in this myself, actually, and I'm happy to introduce Boyan Mihaylov for trying to work with WebAssembly. Good luck.
Thank you. Welcome everyone. Before I start, how many of you have heard about WebAssembly? All right, most of you. And how many of you have tried doing something with WebAssembly or playing around with it? No one. All right, that's good. Then I hope you'll find something interesting today. WebAssembly is a compiler target for the web. It allows us to compile from static languages
like C, C++, Rust, and run this into your browser or into a Node.js environment. So when I say compiler target, what does this mean? If we have program written, let's say in C, we can compile this program on Windows or Linux and execute this program. So now we can reuse the exact same program, use a different compiler, compile this to WebAssembly, and run this into your browser or inside Node.js. So the key point here is that we are reusing the same code base. We don't do any kind of changes. It's just the compiler that does something for us. Traditional way to distribute your programs, now we are developers, so we want to distribute our programs to as many people as possible, is to compile your program to Windows, Mac, Linux. However, it's not that simple, because we are not only compiling for operating system, we have to take into consideration the CPU instruction set as well. So things kind of get really complicated for us as developers to spread our programs to as many people as possible. WebAssembly simplifies this process for us, because now we can use the virtual machine of WebAssembly that resides in the browser or Node.js to do this transformation for us. So now we can compile only to WebAssembly, one compilation, and then the rest happens for us. Before we continue, let's see why WebAssembly was born. What was the need for that? This here is a simple function written in JavaScript. It adds two numbers, A and B. Well, to be honest, I like this to add two numbers, but JavaScript is highly dynamic language. So in reality, A and B could be anything. Could be strings, booleans, objects, whatever. And if we have this simple function and we try to play around with it, we can get very interesting results. So if you try to add numbers, it will probably add numbers. However, if you try mixing the arguments, then we can get some different things out there. And if you say, well, I mean, addition could be translated to concatenation if they're not numbers, JavaScript gets kind of really weird when we started using other operations with the same logic out there. And if you are dealing with these kind of projects and trying to see what the problem is with JavaScript, at some point you may get into really, really weird issues. So JavaScript is not really good at handling types in this way. That's why WebAssembly comes as a type language. It supports types, as does C or C++, for example. And so far, we have two types. We have numbers, floating point numbers, and integers. However, WebAssembly is extensible, and more types are to be added later on. How does WebAssembly look like? So this is a binary representation of the same add function that I showed before, encoded in the binary representation of WebAssembly. Well, this doesn't say anything to us because it's just numbers. However, this is what browsers are going to consume. They're going to download the WebAssembly module, decode this, and then compile it and execute it out of there. For us as humans, we like text. So that's why WebAssembly comes also as a textual representation of exactly the same program. And if you're familiar with languages like Lisp, this would seem very familiar to you. And you can see this is the exact same function of adding two numbers where we have the parameters as integer and the result is also an integer. So now we can actually see this and we can get an idea what is happening behind the scene out there. WebAssembly provides consistent predictable performance. Why is that? JavaScript virtual machines are created by different vendors. So each browser vendor has its own virtual machine, and they use different tricks and heuristics to optimize your JavaScript code, which makes it a bit difficult for us as developers to predict how our applications would perform under different browsers and different operating systems. With WebAssembly, we get this a bit more easily because we can argue about the performance on different browsers. How does this look like? There is one person who created some crazy robots dancing and coming towards you. And he implemented this animation in JavaScript and then in a different language that was later on compiled to WebAssembly. So he wanted to compare the average animation time between JavaScript and WebAssembly to see how huge this difference is. And apparently the difference is quite huge on the different browsers. And although it's not exactly the same, you can get an idea how faster WebAssembly could get on those browsers. Now you may think, well, if WebAssembly is so fast, shall we then compile everything to WebAssembly and execute it? To be honest, WebAssembly is fast only in certain occasions where we deal with computations. We have spent so many decades on optimizing JavaScript. So JavaScript is already quite performant. And many applications that run today in web, they perform quite well, even better than WebAssembly would do them. So in our case, we need to really determine whether we want to use WebAssembly or not. But if we need to do something with gaming, encodings, streaming, things like that require a lot of computation, WebAssembly is probably a very good fit for us. Another big advantage of WebAssembly is that suddenly we can reuse code on the web without needing a third-party plugin, because all the browsers support WebAssembly today. And this is not going to decrease the user experience. This is not going to cause any troubles for us. So they can just use this. Cool. What can we do exactly with WebAssembly? Can we see some real case examples? And sure, I have prepared one of my favorites, and there are plenty of them out on the web. Well, if you are a big fan of Windows, especially the old operating systems, you can actually run them in your browser very, very safely. So you can go and play around, let's say, Windows 2000, or you can go to other versions as well with that. And this is running only in your browser, no internet connection required to run this, of course, unless to download the WebAssembly files. If you are a fan of the games, especially these old-style games, you can even go and play those games in the browser again, thanks to WebAssembly. This runs in your browser. By the way, Prince of Persia is my favorite game, and I'm still just opening once in a while playing it in the browser. I think it's pretty cool. Or if your administrator doesn't allow you to install any kind of editor on your machine, you can have Vim running in the browser as well. It's completely free for you. And the big advantage is that you can use the browser to close it, so no more problems with closing Vim. I think that's a big advantage. All right, how does one start with WebAssembly doing some stuff? Well, I think one of the simplest ways to get started is using something called Wasm Fiddle. And if you're familiar with other tools like JavaScript Fiddle or CSS Fiddle, this is exactly the same concept. So let's try to take a look at this and play a bit around to see what we can do this. So in Wasm Fiddle, you get this kind of screen. So here on the top left button, we have source written in C. This is the default. It's one main program returning 42. Very, very boring and simple program. So now I can build this one. I click build, and here down, I can see the textual presentation of WebAssembly. So you can see there is one function main, and it returns a constant of 42. Pretty simple. And here on the right side, we have the JavaScript code to load WebAssembly. Today, we need some glue code to load WebAssembly in the browser, and there is this WebAssembly namespace containing all the methods and objects that we can use. So what we do is we are creating the WebAssembly module. So here, Wasm code is injected for us, but it's just the binary code of your Wasm file. Then we can create the WebAssembly instance, where we give it up the module, which is compiled, and then we can provide some imports that I'm going to talk about in a while. At the end, we can just go on the instance, we can call exports, and then reach and access all these exported functions from C or the language we are compiling from. So if I run this, then I'll get 42 lockout here. So it's pretty simple. Let's try to play around a bit. So if I come back and try to implement the same function there, so I can say integer A and integer B, right? So I can do this. I can build this one, and you can see here immediately that I get exactly the same function that you saw previous. So now here I can come and then say add something. And here you can see that I get this function created for me. Again, it's pretty simple. What else I could do? Well, in the imports, I can also access JavaScript from C++ and WebAssembly. So this, what you see here, is calling basically C from JavaScript through WebAssembly. But now I can also do the opposite. In C, I can call things that I inject from JavaScript. And these are called module imports. So how does this work? So here I can, let's say, declare a function. Let's say a function that returns an integer. And here I can remove this argument and then call like this. So here I say that, OK, I'll provide a function b that returns me a number. And then when I call add, it will call b and then do the addition for me. So when I build this one, you can see here that on the top, on the textual presentation, there is this import statement that requires me to import a function b in order to initialize this WebAssembly module. To do this, here I can define the imports. So I can say, and this is an object. So this is a JavaScript object. And then you can see it should be in environment. And then here I can say, well, this is a function that is something, and then it's just a function that returns 5, let's say. So now here I can do something like this, and then if I run this, let's see if we do something, it's not that happy.
Yeah, the equal sign after the b should be a column, right?
Where is that?
Well, you write b equals inside your object.
Oh, thank you. Exactly. And yeah, now we get 7 as a result. So now what it's doing is that we are calling basically from JavaScript, we are calling our add function, and then it's calling the imported function again, and this way we have basically allowing both communication between JavaScript and WebAssembly and JavaScript. And we can import whatever we want to and access these functions like this. All right. So this is just the beginning. This is how you can start playing out with WebAssembly. The cool thing about this is exactly this integration with WebAssembly and the outside world. In this case, it was JavaScript. So we can import things into WebAssembly and export things that are callable. It's quite a popular thing that we use in any kind of modular systems. We have some public interfaces and then require something to be injected into our module in order to work. So it's exactly the same concept that we have with WebAssembly. However, if you have a really huge code base written in C or C++, doing something like Quasm Fiddle is not really going to help you. You need a really good and strong compiler with that. And fortunately, there is Mscripton, which is open source compiler that allows us to build and compile from C and C++ into WebAssembly. And the cool thing about Mscripton is that it, besides the compilation to WebAssembly, it gives you also a really solid JavaScript API on top of it that allows you to do these manipulations and call things to WebAssembly and from WebAssembly. So if you have a really huge code base, this is the way to go. But now we are at the PHP conference, and the question is, can we do anything with PHP and WebAssembly? This is where we can talk about some interesting things. What can happen there? And now I'm going to go through some scenarios and discuss each of them and see what are the pros and cons and what the state of these scenarios are there. So what about, PHP today is interpreted most of the time, right? We have the PHP script that is interpreted. What if we could compile the PHP interpreter to WebAssembly? This would allow us to basically interpret PHP scripts in the browser or in Node.js environment. And how does it happen? So today what we have basically like this very simplified version of what we do most of the time. We have the script, then we have the send engine, and then we have some output, most of the time some HTML or JSON or whatever output we have decided to create. So what we could do instead, let's say we could compile the send engine to WebAssembly. So then what is going to happen is the browser will fetch the WebAssembly module. We need this JavaScript glue code to instantiate WebAssembly, right? And then we have one really nice function called then-eval-string, which takes a PHP script or a string as an input, and then it returns the output there. It prints it out in the console, basically. So what we could do is we could call this method with any kind of PHP, and then we can take the output and put it into some DOM element, whatever. We can just call inner HTML and replace the contents out there. So this would allow you basically to do evolve PHP in the browser. And the cool thing is that this is already done and it works today. Let's take a look and see how does this work. So there is a person who compiled really the PHP, the sources. So this is, you can see this is the version 7.4 out in the browser. So what you have to see here is exactly this. The interpreter, PHP interpreter, is compiled to WebAssembly. So here now I can run this, and this is going to execute only in the browser, so no server involved. So I can do something like this, right? And then it will just change the output out there. I can do some functions, so I can do the same thing. So I can do something like this, right? And then I get the result out there. And so by doing this, I can actually manipulate all these scripts and do whatever I want. I can actually also do some JSON encoding if I want. So I can have some arrays here. And I can say something like, and then you can help me. Let's see. And then you need to just use this. So I can do whatever I want, basically. And this is, again, there is no connection to a website. This runs in your browser right there. And let's see what has happened. This project is on GitHub. So if you go there, you can see it's pretty simple. There isn't much code there. What is interesting, it resides here in the build script, how this is built. What this person does is basically, well, he downloads the source code for a certain PHP version, and then he uses mscripton to compile all these things for us. So you can see we have creating the configure here that creates the make file for us, and we can choose what to enable, what to disable here. And then in the end, we are using we're calling make. And then we are using the mscripton compiler to compile this to the final WebAssembly version out there. So this is how powerful mscripton is. It gives us all this framework out of the box. This is pretty cool. Now we can actually do evolve on PHP scripts in the browser. But then you say, well, cool, I don't want to distribute my source code to the browser. This might contain some interesting things that I don't want my end users to see this kind of logic into the browser. So then what about if we did something else? What if you compiled WebAssembly, PHP entirely to WebAssembly? So we can write some code, some function in PHP, and then compile everything to WebAssembly out there. And for many years, Facebook started a project called Hip Hop for PHP. And Facebook, they have a huge code base written in PHP. So for them, performance is very, very important to do. So that's why they started this project. And what it basically did was that it transformed PHP code into C++, and then they used the G++ compiler to turn this into a native code. And they saw a really increased speed on this thing. So now the cool thing is that if we follow this, we could use this C++ version and compile this with mscripton to WebAssembly. And this would mean that we would have the flow chain from PHP into WebAssembly quite well to do that. So this project already brought a lot of new things out there. It didn't support the entire PHP specification. It didn't, for example, support Evo. And apparently it was discontinued at some point. Because later on, Facebook created an additional version. It's a hip hop virtual machine. that does something different because it transforms, it takes PHP script and transforms this into some bytecode out there and then uses the just-in-time compilation to turn this into a native. So from this chain, we can't really benefit to compile this to WebAssembly because then we have to take into consideration their intermediate bytecode representation and write a compiler to turn this into WebAssembly. And as this is a proprietary, so it's not really a standard, it would require a lot of effort to do this. So from this point, it's not really helpful for us. If you search on the internet for PHP compilers, you actually get a lot of results. So compiling PHP is not really something new. This is an idea that has been out there for many ages. And there are projects trying to compile PHP to native, to C++, to .NET, to Java. However, most of them are unfortunately discontinued. And you can see the only active project is PHP that transforms PHP into .NET code. And from there, because .NET is also a virtualized language, you need .NET virtual machine in order to execute this. So it doesn't really benefit, doesn't help us that much if we want to transform this into WebAssembly. For us, the best way would be to transform PHP to C, C++, because from there we have a really stable compiler in the face of Emscripten. So, but still, these projects, they're live on GitHub, and they support at least some parts of PHP. And if you had some old code bases, you'd probably be able to use this to turn this into WebAssembly. Well, what if we did something else? What if we consumed WebAssembly in PHP? Could this happen? Which means that this will allow us to actually reuse code from any other languages, because if you could produce WebAssembly, not only from C, but Rust, Java if you want, then it means that in PHP suddenly you can consume this language, and it should be quite fast according to the WebAssembly specification and the test result out there. And initially, WebAssembly was created to run inside the browser. However, many people saw great potential in this. So that's how the Wasmer project was born, to take WebAssembly out of the browser. And what Wasmer does for us is it creates a CLI that you can install in your Linux or Windows machine, and you can execute WebAssembly scripts basically there. So it comes with a virtual machine in a separated CLI. So you no longer need the browser or Node.js environment to run WebAssembly scripts. And the cool thing is that Wasmer projects provide an API that allows us to, because the virtual machine is there as C and Rust code, so it provides an API for us to consume this and build integration on top of this for different languages. And that's how one person has written a PHP extension that you can compile and include this in your web server, let's say, and consume WebAssembly in PHP. How does this work? Well, this is an example. For example, if you have the same add function written in C, we can compile this to WebAssembly, and then we can use this PHP web extension for WebAssembly and of course, some glue code on top of it that makes it nice. So we can instantiate the module, and then again, we can call our method inside PHP. And I wanted to play around with this, so that's why I created one project called Sudoku Battle. And this project is very simple. Basically, this is Sudoku, and I have found one person who has implemented Sudoku Solver in PHP, and I have also found another person who has implemented Sudoku Solver in C, just on GitHub. So I have compiled this C version to WebAssembly and created two PHP services to solve my Sudoku, one using PHP, the other using WebAssembly to see that. So let's see. So I basically, on every row of the page, I generate a hard, supposedly hard Sudoku here. And if I try to solve this with PHP, let's say it can take 1 to 1 second and something. If I try to solve the exactly same Sudoku using WebAssembly, it is actually enormously fast than that. And no, it is doing the exactly same thing. It is solving the Sudoku. Of course, you can argue about the quality of the algorithms to solve Sudoku written in PHP and WebAssembly, but the difference is really huge. And you can play around at some point. For some Sudoku, of course, PHP gets a bit faster, but still, WebAssembly is much faster than that. And how does this look like? So let's say, so this is my very, very simple project here, and this is the C version of my Sudoku. So what I do is I represent the entire Sudoku game as a sequence of numbers. So it's basically one string with length 81, so 9 times 9. So I'm taking this. I'm giving this to my function, and then I'm getting the result out of it. And this is the same in PHP, and this is the C version here, right? So I use mscripten to compile this to WebAssembly. So this is how it looks like. So I'm calling the mscripten compiler and say, hey, please compile this as a standalone to WebAssembly without JavaScript API, and please export the solve function for me because I want to call this. And then here I have my PHP service that consumes this. So what I'm doing, I'm parsing basically the JSON from the post data. And now, because at this point, I mentioned that WebAssembly supports only numbers, right? And I want to use strings to represent the entire game. So here, what I'm doing, WebAssembly has internal memory that the module exports. So what I'm doing is I'm encoding the string in the memory and thus allowing the C version to read it from memory afterwards. And then the result gets encoded into memory, and I decode it from PHP afterwards. So you can see. So if I have here my instance, then I get my memory buffer from this instance. And then I have a function that writes this into the memory. So I say, hey, how does this look? Well, you can see it's just an offset where I just write encode the string byte by byte on this memory. And then when I'm calling my function in C, I'm giving actually a pointer to this memory. And there, C will be actually able to decode the string and use it, right? And the result is another pointer, because I can't really return the string itself. So I'm returning a pointer to the memory where I'm actually reading this, again, the same thing. So I'm starting, and because strings in C are represented by a sequence of characters or bytes, and then at the end you have this no character to signal the end of the string. So this is what I'm doing to decode the string, and then sending it back out there. And by doing this, I can actually manipulate and the memory and communicate between C and WebAssembly. And how does this? So usually when we have a PHP script, we have the script, then we have the boot where we are parsing the script, then we are executing it, and then this is tear down. So which means that on every request, if we had this, we had to parse and decode the WebAssembly file, then compile it, and then run it, and then destroy this. So we'll have some cost on each request. And this is probably not really cool if you have a really big WebAssembly module that we want to do. So what we could do there is we could replace this decoding compilation with serialization, deserialization. Because WebAssembly modules, they allow to be serialized. And that means that we can cache them, either in some SQL database or a Redis server or Memcache, depends on whatever you want. So we can actually transform the decoding compilation overhead into deserialization afterwards, which is faster most of the time. I mentioned this memory thingy. So WebAssembly uses so-called linear memory to operate and write things. When we write programs in C and C++, we are used to deal with memory, to grow memory, free memory, things like this. And when you hear memory, you might think, all right, how does this work on the web? Because you know that memory in programs like C and C++ is one of the kind of the worst things to manage, especially in worst big projects, because if we are not careful enough how we deal with memory, we can expose things that are not supposed to be exposed out there. The good thing is that the virtual machine, the design of WebAssembly is done in a very secure way. So what WebAssembly sees is just basically an array that pretends to be a real memory. And this array is with a definite start and endpoint. And there are hard checks in the virtual machine to make sure that we are not able to access anything outside this. And the trick that we use now is that the memory is our glue between WebAssembly and the hosting environment. So we can use the memory to write stuff and then read stuff from it, as we saw with the string. So what we did here was basically we encoded string in the memory and then decoded it afterwards. This is how we can transfer complex data between WebAssembly and the hosting environment. All right. how secure is all this thing? Really, it runs in our browser, and you remember probably that I think last year we had this issue of Spectre and Meltdown into all the browsers, which allowed things to be, your CPU to be manipulated and exploited in some occasions. And many people start wondering, okay, how will WebAssembly actually contribute to this security? Is it going to make it worse, or are we safe there? And the good thing is that WebAssembly reuses a lot of the architecture, the security architecture that we have for JavaScript today. So it comes with a sandbox, which means that we can't access things outside this sandbox unless they're part of the WebAssembly specification out there. So we are pretty safe with WebAssembly. You can't do things with WebAssembly that you normally can't do with JavaScript. And now this was just one example with PHP and WebAssembly, but the reality is there are so many other languages that can compile to WebAssembly, and what I did was I played around because I really wanted to see how different languages compile to WebAssembly. So that's why I created the wheel of WebAssembly, which is similar to the Wheel of Fortune. However, you don't really win anything here. But what you see here, these are a couple of languages that perform exactly the same thing. They give me first their name, and they give me a function that can generate a random number between 1 and 100. So what I can do is I can spin the wheel, and here I'm calling Java compiled version of WebAssembly that generates this number for me. And all these sectors or wheel parts are completely independent of each other. And this just shows how powerful WebAssembly is. It allows us, you don't really care anymore what language we can compile from. You only care from the API that you need to consume. And you can do this in JavaScript, or you can do this outside JavaScript in PHP or any other language of your choice. So suddenly, WebAssembly becomes let's say, the intermediate language of the web. What else? I mean, WebAssembly began to spread not only in the JavaScript, but people started using it to create frameworks on top of that. Today, we use mainly Angular, React to create front-end applications. But hey, Microsoft started with a very simple project to use WebAssembly to allow us to use .NET to create front-end applications. So Blazor it started as an experiment, but now it grew into something really more stable, which means that now we can use .NET to create front-end applications just like you use Angular or React. So it's the same thing, and everything this is powered by WebAssembly, so you can go out and play around with it. And Microsoft was just the first movers on this, because people start experimenting and creating the same thing in any other languages. So now you can actually have similar things in Go, if you prefer to use Go to create these kind of things. You can actually have a spasm if you really wanted that. So WebAssembly allows us to actually use our favorite language and don't care really where it is going to be consumed, because the virtual machine is supported in so many environments out there. And I really believe that WebAssembly is allowing us to move the web further by using code that was written by many people, and there are so many libraries on GitHub, and WebAssembly makes this code accessible for us there. So I really believe that WebAssembly is a game changer for us, and no matter if you do web or not, WebAssembly is something that you could play around because it will allow a great interoperability between languages out there. So now the only thing that we should care about is API and consuming API. My name is Boyan, and thank you so much for coming for my talk today. I think we have a couple of minutes for some questions.
So it is hard to move the desktop application to the web? I mean, let's say we have like a drawing application, AutoCAD. We want to move it to the web. How it's complicated and how it should be done?
Very good question. So if you want to move desktop application, you have a different scenario. So if this was written in something like C and C++, you would probably be using OpenGL for that. If you want to use this in the web, you'd use something called WebGL, which is a web standard that allows you to do these things. And mscripton supports this. So if you use mscripton to compile, this will be actually supported out of the box for you. So you can actually compile this, and you'll get a WebGL version out in the web. Another thing that you could use is that you can actually build desktop applications for any language, because you can use Electron, which use Chromium out of the box. So suddenly, you can build things in WebAssembly on whatever language you want, compile to WebAssembly, and distribute this with your Electron-based applications. So suddenly, you support a lot of applications for Windows and Linux. All right, I mean, I've been hanging around here, so please feel free to reach me. And if you have any questions, I'll be happy to discuss them with you. Thank you so much for coming.
Great. Don't forget to rate Boyan
On John Tin, yes.
Exactly.